Okay, so what we have been looking at is we've been looking at, within hypothesis testing, what is the null and alternative hypothesis, and then we've been looking at our Z statistic, or our X bar mean, and we got to the point of saying that the further away from the mean of our population that is, then the less likely that the null hypothesis is true, and the closer it is to the mean, the better it supports or gives some evidence for our null hypothesis. So what we're going to do now is we're going to actually work with some values to sort of quantify when we can say we reject, or there's not enough evidence to reject the null hypothesis. So we're going to quantify some of that. So a hypothesis test, or a test of significance, assesses the evidence against the null hypothesis in terms of probability. So now what we're doing at the moment is we're looking at evidence against the null hypothesis. So the probability is calculated under the assumption that our null hypothesis is true, so H naught is true. So the probability is based on the idea that the test statistic will take a value at least as extreme as the actual observed value, and it's called the p-value. So just to give you an idea of what's going on here, I just want to swap over to just like an interactive whiteboard. And so if we have our normal distribution, that is a terrible normal distribution, sorry, I probably should just get one that's a little bit more usable. So not that that's much better, but we'll go with that for the moment. So this is our normal distribution, and then what we're saying is, well, our Z statistic is going to tell us how far away from our actual mean we are. So if we're sort of out here, this is our sample, that's the mean of our sample out here, and this is the mean of the freezing temperature of normal milk. Then what we do is we look at this area here, and then on the other side we draw the equivalent value here, like that. So that's the equivalent distance from the mean that this value here is from the mean. And so we say, well, if this is our mean, if we assume the mean to be what the claim was, or if we assume the mean to be what it was for normal milk, then what's the probability that we're going to get a mean of a sample at this point, or more extreme? So more extreme also includes this side. So what we're looking at is, what is the probability of it being here or more extreme, or here or more extreme? Okay, so we find the probability of it being at the observed value that we got, or more extreme, and that's that probability. So the sum of those areas there is what we call the p-value. So it's that area plus that area there. So that's our p-value. So the smaller the p-value, the stronger the evidence is against our null hypothesis, because what we're saying is that a value at this point or more extreme is not very likely at all for having the mean here of a normal milk freezing temperature. And so if it's not very likely at all, then that suggests that we don't actually have this mean, we have another mean, and so water must have been added to the milk to change the freezing temperature. So if the p-value is as small or smaller than alpha, then we say that the data are statistically significant at the significance level alpha. And down at the bottom of the page we have some explanations of what we mean in statistics by extreme and significant. So what we're saying is that if that area, the sum of the area there and the sum of the area there, or the sum of those two areas, add up to give us something less than alpha, then that's where we're saying, well, we're going to reject the null hypothesis, and if it adds up to something more than alpha, then we don't have enough evidence to reject the null hypothesis. So what we generally use in this course is we set alpha to be equal to 0.05. So this is a significance level of 5%, and that means that the observed result that we've got would occur no more than 1 in 20 times. So if you took 20 different samples of the same size, then you would expect only one, at most one of them, to be having a value which is either here or more extreme, or here or more extreme, if that's our 5% level. So if those two areas add up to give us 0.05, that's what we'd be expecting. And this is often referred to Fisher's 0.05 because he's the guy that came up with it. So now what we say is if our p-value, so the sum of those two areas on the outside, is less than or equal to 0.05, then what that tells us is that for the mean being the same as the mean of normal milk freezing temperature, if this area out here is less than or equal to 0.05, then it's unlikely. It's very unlikely to occur, and so that suggests to us that the mean is not the same as the normal freezing temperature mean of milk, but it's actually different. So we're going to, if that happens, we reject the null hypothesis, and if p is greater than or equal to 0.05, then what we say is we don't actually accept the null hypothesis because we're not really testing. Our test doesn't tell us whether it's true or not, but we say there is not enough evidence to reject the null hypothesis. So rejecting H0 is saying that H0 does not provide a plausible explanation for the observed data. So what it's basically saying is that if this area, if the sum of these two areas here is less than or equal to 0.05, then for this mean being the same as the mean of normal milk for freezing temperatures, then it's very unlikely that we'd get an observed value here or greater, or here or less than. So that tells us that this mean doesn't give us a plausible explanation for the mean at this particular value, doesn't give us a plausible explanation for why we observed it here, why we observed the mean of our sample here, and so on the basis of that we reject the null hypothesis. And then if it's greater than or equal to 0.05, there's not enough evidence to reject the null hypothesis. So extreme in statistics, extreme is relative, so it's far from what we'd expect if H0 is true. So extreme is sort of talking about values right out here with a low probability. Significant is talking about that's evidence against H0, so that's why we call it significant, because it gives us evidence to reject H0. It doesn't mean the same as important, it's just talking about evidence against our null hypothesis. Okay, so now I want you to do worksheet 2.10, which I will have handed out to you. Okay.